Section 10.3 talks about the famous Maclaurin series, and this is how the Maclaurin series works. We take a function f of x, and we say let that be like a polynomial except an infinite polynomial. So if I want to write this as a summation that runs from 0 to infinity, c sub n x to the n, again let n equal 0, let n equal 1, let n equal 2, and so on and so forth. So the key, it turns out, is finding c sub n. X to the n, we already know what that is. No x, or x to the 0 if you might, x to the 1, x squared, x cubed, x to the 4th. Meaning we could take any function or relation BD on the long run in math and write it as a power series. And the power series consists of a polynomial-like series. So to find c sub n, what we do, we say, alright, look, if you find f of 0, that is c sub 0, that will be 0, that will be 0, that will be 0. All of these terms will be 0 all throughout, so I'm left with c sub 0. So I know that f of 0 is c sub 0. I'm trying to figure out a formula for c sub n. If I look at a derivative, if I take a derivative of this, that would be 0. You see it's no longer there. The derivative of c sub 1x is c sub 1. Bring the power down, subtract 1 from the power. Bring the power down, subtract 1 from the power. Bring the power down, subtract, and the list goes on. And here, if I say, what would be f prime of 0? And we notice that would be c sub 1. So not much variation there. Now, if I do this again, meaning if I take a second derivative of this, another derivative of that, that will be 0. This would be simply 2c sub 1. You bring the power down, that's 3 times 2c sub 3x to the 1. Bring the power down, 4 times 3c sub 4x squared, and the list goes on. And if I find a derivative of the second derivative evaluated at 0, I'll get 2c sub 2, and I'll notice that the rest of all of these terms, that will be 0, that will be 0, that will be 0. And if I would go ahead, I'm going to line those up a bit better. Just give me a sec. I just rearrange those, line them up. F of 0, f prime of 0, f double prime of 0. And if I take a derivative of this, that will be 0. That would be simply that value, it's right there. Bring the power down, 4 times 3 times 2c sub 4x to the 1. Bring the power down, and there it is. And simple derivative, nothing more. Now, if I am to throw a 0 in there, if I am to take f triple prime and throw a 0 in there, you'll notice I'll get 3 times 2c. I know that's a 6. We're trying to figure out a pattern. That's why we don't multiply. And if I go for a derivative of this, that will be 0. A derivative of this will simply be, well, it's right there. Derivative of this, bring the power down, subtract 1 from the power. 5 times 4 times 3 times 2. So, again, same process. And if I figure out what is the fourth derivative evaluated at 0, I would notice that that's a 0, and all the other terms after that will be 0. I'm left with 4 times 3 times 2c sub 4. So now if I look for a pattern, now I'm looking at the right side only. I'm looking at those. F of 0 is c sub 1. So here it's sort of like you're not taking a derivative, sort of speak. Right? Here you take one derivative, you get c sub 1. Okay. Second derivative, c sub 2. Third derivative, c sub 3. Fourth derivative, c sub 4. So the nth derivative, according to the formula, according to the pattern I'm figuring out right there, I'm getting that to be C sub n. Now, I look at this, and I notice that if this is the fourth derivative, this is 4 times 3 times 2, which is 4 factorial. If this is the third derivative, 3 times 2 is 3 factorial. Second derivative, 2 times 1 is 1 factorial. First derivative, 1 factorial is 1, and no derivative, 0 factorial is 1. So it seems right to write n factorial C sub n. That is, if I want to check, out of nowhere, if I want to take the third derivative, it turns out to be 3 factorial C sub 3. This is 3 times 2 times 1 C sub 3, and if we match it, there it is. And if I divide both sides by n factorial, I will get what C sub n is. C sub n is the nth derivative evaluated at 0 divided by n factorial. So, I can take any relation in math, f of x, let's say functions for now, and I could write it as a power series, like we said, except now that I know what C sub n is, I could say, well, it's really right there. And if I really want to expand this, well, I know what that is. If I take the initial f of 0, C sub 1, well, we know C sub 1 is f prime of 0, f double prime of 0, f triple prime of 0. Ooh, I left something out. Give me a sec. They're much better. So, f of 0, f prime times x to the 1 over 1 factorial. Second derivative will be multiplied by x squared over 2 factorial. Third derivative will be x cubed over 3 factorial, and the list goes on. So if you really pay attention to this, every problem will consist of a number which is f of 0, the derivative of f evaluated at 0 times x to the 1 over 1 factorial, the second derivative of f times x squared over 2 factorial, third derivative times x cubed over 3 factorial, fourth derivative times x to the 4th over 4 factorial, and this way we could write any relation in math as a power series. So we have some examples to look at, and let me start with the first example. Now this book is very specific. Normally they say find the power series, find the Maclaurin series. I got a warning, there's another series called Maclaurin, but Taylor, but this book doesn't talk about it. So we're gonna match the book. And normally they say find the power series for cosine of x. Here they're giving you the problem and they're giving you the answer, but you have to show it. So this is what you do. This is obviously f of x. So what you do, you go on the side and you make a table. Say, alright, let's look at this table. And the table is going to consist of, and let me write this out so we know exactly what's going on. There is f, and there is at x equals 0. What we're doing, we're taking cosine of x, and according to the formula up there, that's going to be f of 0 plus f prime of 0 x to the 1 over 1 factorial, f double prime of 0 x squared over 2 factorial, triple prime of 0 x cubed over 3 factorial, fourth derivative at 0 x to the 4th over 4 factorial. Now how many of those terms do I need? I keep on writing those terms normally until I figure out a pattern. In our case, in this class, we just have to write enough to match those. So what's f? F is the cosine of x. So if I take f of f equal cosine of x, evaluated at 0, cosine of 0 is 1. If I take a derivative, that's negative the sine of x. Negative the sine of x evaluated at 0, negative sine of 0 is 0. Another derivative, negative cosine of x. At 0, that is a negative 1. triple prime. Now again, we have to go only up to x to the 6, so 6 derivatives. Third derivative will be a sine of x, and the derivative of that evaluated at 0 is 0. The fourth derivative would be the cosine of x, that's a 1. The fifth derivative, that's negative sine of x, that's a 0. And the sixth derivative is negative cosine of x, evaluated at 0 is a negative 1. So if I fill in the blanks, what does that mean? If I replace f of 0 by 1, if I replace f prime of 0 by 0, if I replace f double prime with a negative 1, if I replace the third derivative by a 0, if I replace the fourth derivative by a 1, and the fifth derivative by a 0, right? And there's one more. I can shorten this a bit. So it's a bit of busy work, really, but not much variation. So I know that the sixth derivative, since I've been doing this, shift up, here we go. And I know that's going to be the sixth derivative. I would know that that is negative 1. Okay, and how does that work? Well, let's see. This says cosine of x is 1 plus x to the 1 over 1 factorial minus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4 over 4 factorial plus, and we know those are going to exist in all the problem. Every problem you could write like that. The question is, what's the coefficient? And we know that the cosine of x equal 1, that's a 0, minus x squared over 2 factorial plus 0, plus x to the 4 over 4 factorial plus 0 minus x to the 6 over 6 factorial, and the list goes on. Now, generally speaking, you're supposed to write the series n equal to infinity, and you figure out the pattern. And since the book doesn't do that, we're not going to worry about that. We're just going to let it go. So we're just going to match what the book wants. This right here, you do not need for this class. Unlike if you've taken AP Calculus, BC, or you've taken Calculus, then you would know how much painful this is. Now, what if I was looking at the cosine of 3x? Well, the same deal. I'm going to have to make the table. And here's the table. So this is what I'm going to say. I'm going to say that cosine of 3x is going to be f of 0 plus f prime of 0 x to the 1 over 1 factorial f double prime of 0 x squared over 2 factorial plus triple prime. You normally don't have to go to 6 because the only reason we're going so high here because we know that cosine is going to alternate and we're going to lose half of the terms. So normally 3 terms or 4 terms will do. Right? So let's say we're going to stop here, plus the list goes on. So what I need, cosine of 3x is going to be, I just need to know what those coefficients are. That is, I need to know what this is. I need to know what this is. And those I'm going to find on every problem in this section. And that turns out to be the bulk of the work in this section. So I will go on the side and say, let's say f is the cosine of 3x. I need to evaluate this at 0. So you need to leave yourself some space. At x equals 0, well, I know this is a 1. If I take a derivative, that is negative 3, the sine of x. Sine of 3x. At 0, that's 0. The double derivative will be a negative 3 squared cosine of 3x. At 0, that's a negative 3 squared. The third derivative will be a negative 3 cubed, the sine of 3x. At 0, that's 0. And the fourth derivative will be negative 3 to the fourth the cosine of 3x positive, and that's going to be a 3 to the 4th. So I know how this works. I know this is a 1. I know this is a 0. I know this is a negative 3 squared. What color did I use on that one? And I know this is a 0. And I do know that this is a 3 to the 4th. So if I fill in the blanks, that's 1 plus 0x to the 1 over 1 factorial minus 3x squared over... So the black part doesn't change. The only part that's varying is the coefficient, and that turns out to be all the work that we need to do. So I could say that cosine of 3x is actually 1, that's a 0, minus 3 squared over 2 factorial x squared, that's a 0, plus 3 to the 4th over 4 factorial x to the 4th, minus the list goes on. And that's pretty much what we have to do in this section. Again, a bit of busy work, not that hard. Let's look at the next problem up. And here we go. We're going to say e. Okay, it's not registering. Why is that? Give me a sec. We're going to say e to the 4x is going to equal f of 0 plus f prime of 0 x to the 1 over 1 factorial plus f double prime of 0 x squared over 2 factorial triple prime of 0 x cubed over 3 factorial. And you don't have to go that high because sine and cosine are pretty much the only functions that lose a term. Here you can get a lot of terms. So if I make my table, and here we are. F is e to the 4x. At x equals 0, e to the 0 is 1. A derivative will be 4e to the 4x. At 0, that's 4. F double prime, 4 times e to the 4x. Derivative of that, e to the 4x times 4. At 0, that's 4 squared. Again, we don't multiply those because we're trying to figure out a pattern. That's going to be 4 cubed, e to the 4x, that's 4 cubed. Maybe one more for the heck of it. That is 4 to the 4, e to the 4x. At 0, that's 4 to the 4, e to the 0, which is 4 to the 4. So what I need to know what this value is. It's right there. I need to know what this value is. It's right there. I need to know what this value is. It's right there. I find all of these values, and pretty much that's all I have to do. So this would be, so e to the 4x would be f of 0, that's a 1. That is a positive 4. That is a positive 4 squared. A positive 4 cubed. When you don't lose terms like that, you don't have to list that many terms. So if I really look at this, that is 1 plus, this is x to the 1 over 1 factorial, x squared over 2 factorial, x cubed over 3 factorial. And don't forget, this is infinite. So e to the 4x is really 1 plus 4 over 1 factorial x to the 1 plus 4 squared over 2 factorial x squared plus 4 cubed over 3 factorial x cubed plus 4 to the 4th over 4 factorial x to the 4th, and the list goes on, and that's really what this is. They like to see the number and x to the 1, the number and x squared, the number and x cubed, and that's how it works. Now, what is this used for? This is how we program computers, calculators, to evaluate what e to the 20 is, what e to the 17 is. And how about this problem? The same deal. By now, hopefully, you're really comfortable with this. ln of 1 minus x is f of 0 plus f prime of 0 times x to the 1 over 1 factorial plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 x cubed over 3 factorial, and the list goes on. Maybe one more, just for the heck of it. Plus the fourth derivative at 0 times x to the 4 over 4 factorial. So I need to make my list. Here it is. I'm writing f. F is natural log of 1 minus x. At x equals 0. If I put a 0 there, natural log of 1 is a 0. What's the derivative? Derivative is 1 over 1 minus x times negative 1, which is negative 1 minus x to the negative 1. At 0, that is a negative 1. If I take a second derivative, that is 1 times 1, that's positive. Negative times a negative. 1 minus x, subtract 1 from the power, times the derivative of the inside. So if you plug a 0 right there, you'll get negative 1 times 1, which is negative 1. 2 more derivatives and I'm home free. Third derivative. If you bring the power down, negative 2 times negative 1 is a 2 times 1 minus x to the negative 3 times by the chain rule. If you put a 0 there, you get a negative 2. And if you take one more derivative, the fourth derivative is going to be, this is again negative 2, so that's going to be negative 2 times negative 3 into 1 minus x to the negative 4 times negative 1 by the chain rule. If I put a 0, I get negative 1 times negative 2 times negative 3, which is negative 3 times 2 times 1, or factorial. So I could say natural log of 1 minus x is actually f of 0. F of 0, I got it to be 0. Plus f prime of 0, I got that to be negative 1 x to the 1 over 1 factorial. Plus f double prime, I got that to be a negative 1 x squared over 2 factorial. Plus the third derivative. The third derivative is a negative 2 times x cubed over 3 factorial. The fourth derivative is negative 3 times 2 times 1 times x to the 4th over 4 factorial, and the list goes on. So I could say natural log of 1 minus x is negative x minus x squared over 2 times 1, minus, isn't this 3 times 2 times 1? Doesn't this cancel the 2? Isn't that x cubed over 3? Minus, isn't this 4 times 3 times 2 times 1? Wouldn't those cancel that? Isn't that x to the 4th over 4? Look at the pattern, and can you guess what the next term is? Negative x to the 1 over 1, negative x squared over 2, negative x cubed over 3, negative x to the 4 over 4, negative x to the 5 over 5. And there it is. That's pretty much it for this section. So it's nothing more than you verifying the coefficient of the series, which is a big deal for us.